We're going to start out a 3-video series on inverse trig functions, and we're looking at how do I take the inverse, or how do I go backwards with trig functions. So before we go backwards, let's talk about going forward again. So looking at regular trig functions that we've talked a lot about so far. Take for example the sine of, let's just pick a value, 45 degrees. And we know, based on reference triangles, we know based on unit circle, that the sine of 45 degrees is root 2 over 2 after I rationalize, normally 1 over root 2. So stop and just think about that for a second. We're taking the sine of, remember that's an angle, and when I take the sine of an angle, I get a ratio of sides. So we take an angle and we get a ratio of sides. Another example quick, if I had something like the cosine of, let's go to radians and say it's 5 pi over 6. Again, I could draw a reference triangle and put my pi over 6 reference angle, or I could look at my unit circle, that's going to be really helpful for this section, and know that this comes out being negative root 3 over 2. But I want you to look past that for just 1 second, and remember, I'm taking the cosine of an angle, and when I take the cosine of an angle, I get a ratio of sides. Some triangle has negative root 3 as the one side, length, quote unquote, and 2 is the other. So when I'm dealing with regular trig functions, the input was an angle, and we just took this for granted. We take the cosine or sine of theta, and we get an output that is a ratio of sides. And sometimes we take that for granted, but it really is 2 sides of a triangle every time. Well, what if we're going backwards? Instead of sine, I'm going to have what I now call sine inverse. I want you to notice something. This guy right here, that is not an exponent of negative 1. What we learned in algebra about exponents of negative 1, taking the reciprocal, does not apply here. That is just a notation saying sine inverse. Now when I take sine inverse, it's going to be a little bit different. I'm going to have to take the inverse sine of a ratio of sides. So for example, I'm going to take the sine inverse of root 2 over 2. And if I go ahead and evaluate that, it's going to end up equaling 45 degrees. So look at the difference here. If I'm using an inverse trig function, my input here is going to be a ratio of sides. And my output is going to be an angle. When we take the inverse, we swap the x's and the y's. We swap the input and the output. We saw that back in pre-calculus. So we're going to swap the ratio of sides and the angle. Another example quick. If I have the cosine inverse, that'd be cosine, what it looks like to the negative 1 power, but it's cosine inverse of something. I need to take a ratio of sides. Let's say my ratio is negative root 3 over 2. So I'm asking myself, what angle gives me a ratio of sides of negative root 3 over 2? And if I look over here at this side, it's going to be 5 pi over 6. So the input, whenever I have an inverse trig function, is a ratio of sides. And the output is going to be an angle. So what this allows us to do is now find angles. Up until now, we've been finding sides, finding sides, finding sides. Now we can find angles. So remember, input is a ratio of sides, output is an angle. So what does the notation look like if I'm dealing with inverse trig functions? The notation is going to look like this. The inverse of sine is going to look like one of two things. Either sine inverse of x, I can call it whatever I want, or I can write it as, it's called arc sine. So sine inverse or arc sine. Arc sine is just a fancy way of writing sine inverse. We're just going to count them as the same. So I can also extend this list to cosine inverse, or what's called arc cosine. And lastly, I'd have tangent inverse, or what's called arc tan. And again, arc tan and tan inverse are exactly the same thing. I'm going to cross out these things at the bottom. Not sure why they're still there. Okay. Two last little thoughts before we end this first video. First one is, what if I have something, I'm going to go to a new page, that says arc sine of 0? What is it asking me for? Well, remember, this right here is a ratio of sides, and it's asking me to find an angle. So I'm trying to find, if I put this into what I'm thinking in my head, what angle has a sine of 0? That's the ultimate question right there. That's what I'm trying to find. And if I go back through and look at my unit circle, or I think about the quadrantals, pretty quickly I'm going to remember that if I have the ordered pair 1, 0, which is cosine comma sine, I can answer this question. I can realize that the arc sine of 0 is, in fact, 0, because the sine of 0 right here is 0. Now, some people are asking, wait, what if there's more points? What if there's more values? Because I'm pretty sure the same thing happens over here. And it does. But for right now, we're not going to worry about more than one answer. So just take this one answer, and we'll expand on that soon. My last example, just one more quick slide, is going to be, what if I have the arc tan, or arc tangent, of 1? Remember what this is asking me. This is asking me to find the angle whose tangent is 1. That's what I need to find. Please remember, I could write this as tangent inverse of 1. These two things mean the same thing. Now, unfortunately, I can't just go to my unit circle and find the arc tangent, but I can think through what I know and draw a reference triangle. Where is tangent positive? Tangent is positive there. All spiders taste, and he's positive down there. For right now, I'm only going to worry about quadrant 1. We'll discuss the other quadrant in a couple videos. So if I draw myself a little reference triangle, and this side, I know that the ratio of sides is 1, because ratio of sides is the input for an inverse. So opposite over adjacent is 1 over 1. And I can recognize this now. I have 1 root 2. And I'm starting to see that I have special triangle. So I just work backwards in my head, and I know that this is a 45-degree angle. So if I'm getting the arc tan of 1, it's going to be 45 degrees, because it answers this question. The angle whose tangent is 1 is 45 degrees. Or I could write it in radians as pi over 4. So all of these things right here are equivalent statements, mean the same thing, and all get to the beginning of this idea of what an inverse function in terms of trigonometry is. Input is a ratio of sides, output is an angle. So we're finding angles now. In the next video, we're going to go through and actually find some angles and look at quick ways and easy ways to do that.